1.03, we learned about the laws of motion. Have you ever played a game of tug of war where two teams get on opposite sides of a rope and they pull, and on either side of the rope is force. Force is simply a push or a pull that's applied to an object. All different forces that are applied to an object make up what we call the net force. We have two different kinds, balanced and unbalanced forces. Forces occur always in pairs. They can be balanced or unbalanced each time. Balanced forces do not cause change in motion. Unbalanced forces, on the other hand, do cause change in motion because they are unequal in their amount of force. Balanced forces. If you've ever arm wrestled with someone who has about the same strength as you, that is a balanced force. Your hands might wiggle a little bit in the middle or push one way or the other slightly, but no one's going to just outright win the arm wrestling competition. That's because we have an example of balanced force. So a net zero here, our net force is zero here. Now if we take tug of war again and we have two teams with equal amount of force pulling, neither team is going to be pulled one way or the other. Again, the net force is zero. However, unbalanced force, if I put you up against this guy here to do an arm wrestling competition, obviously this guy is going to win the arm wrestling competition. His force is much greater than your force. So the net force is going in his direction. Now let's put you and your friends up against him and his bodybuilder friends and in a game of tug of war. And you all get on either sides and start pulling. You and your friends will be pulled into the pile of mud by him and his bodybuilder friends. There won't be any competition there because their force is much greater than your force. So their force is pulling you and your friends towards their direction. Then we also have unbalanced force in which all the force goes in one direction. So let's say my car breaks down and I get behind my car and I start trying to push it. I'm not going to be able to move my SUV by myself. That would be an unbalanced force in my direction. It's not going to move. However, if I ask you and a few of our friends to do it with me, then we could get my car to move with a few other people pushing on my car to move it. That would be the unbalanced force, all moving in the same direction. Then we have friction. Friction is a force that works against motion of an object. It affects the movement of matter. Friction can occur between two solid objects and on objects moving through liquid and gas. Now look at this picture here. We have this mountain biker. She's got the treaded tires and it's grass and mud terrain. Then we have this girl on snow and ice and a little sled. Which girl is going to be experiencing more friction? She's going to have to work more for her mode of transportation to move. Exactly, you're right. It's the girl on the mountain bike because she has a lot more friction, which means there's a lot more force working against her. She has to work harder to get down the hill than this girl does on the sled. She gets to just kind of sit back and relax and slide down the hill while she has to continue to pedal to make it all the way down. Now the whole assignment is based off of Newton's 3 laws of motion. So let's talk about his 3 laws of motion in detail then. Newton's first law of motion, this is what explains that forces need to change motion of an object. So it states two things. One, an object at rest will stay at rest unless acted upon by an unbalanced force. Basically, if it's not moving, it's not going to start moving on its own unless something makes it move, like the wind blows it or you pick it up or move it yourself. Or an object in motion will stay in motion unless acted upon by an unbalanced force. If you kick a ball, the ball is going to continue rolling until someone else stops it or there's enough friction for it to finally stop moving. Then we have inertia. And inertia is an object resistance to change in motion. So when we're in the car and we take a sharp turn, our body will continue in the direction it was originally headed, resisting that sharp turn. Also, let's say that we are on, it's like I'm on a skateboard, going down a hill, and I'm doing awesome. I get down to the bottom of the hill and I hit a curb. My skateboard is going to stop. I am not going to stop. My body will continue flying through the air in that motion I was originally headed. That is inertia. My body is resisting the change in the motion. So my body didn't stop when the skateboard stopped. I continued to fly off of the skateboard in the direction that I was originally headed. Also, catch up. What do? We put it upside down. And we try and shake it really hard for it to come out and then finally stop it really sharp. And that is what makes the ketchup dislodge and come out of the bottle. Newton's second law of motion. Newton's second law of motion is when the mass of an object directly depends on the force and the acceleration. So you're going to be able to go faster depending on the amount of force and mass that you have. So I've got a 5-year-old daughter, and I'm pushing her on a swing with one hand. She'll go fairly high, but what happens if I start pushing my daughter on the swing with 2 hands? I'm applying more force to the same amount of mass, and so that means her acceleration will then increase. Think of when you're sitting at a stoplight next to a semi-truck. When that light turns green, who can leave the line faster? You or the semi-truck? About you and 5 other cars can go before the semi-truck finally gets back up to speed. This is because the semi-truck has a lot more mass than your car, which means it takes a lot more force to make that semi-truck accelerate. So let's see what happens when we have a small mass and a large mass. It is no problem for the person with the bike to move it, but the person with the car, with a lot more mass to move, it makes a lot more force to make it accelerate. And the formula is acceleration equals net force divided by mass, or force equals acceleration times mass. And then we have Newton's third law of motion. Newton's third law of motion is that every action has an equal and opposite reaction. So let's take this swimmer for example. Swimmers, anytime you swim, you put your arms in front of your body, towards your head, in front of your head, and then push your arms to the back of your body towards your feet. So you're moving, your hands are moving back towards the back, but your body is propelled forward. So that's the opposite. The equal part is however much force you are applying back when you're swimming is the amount of acceleration you'll have in the forward motion. Take a basketball, for example. Have you ever dribbled a basketball? When I drop a basketball from my hand, when it hits the ground, does it stay on the ground? Of course not. It bounces back up to my hand. Now let's increase our force. I slam my basketball down on the ground. It's not going to just bounce up to my hand this time. It's going to fly way up over my head. This is because I've applied a larger force, and so a larger force will now be applied back in the opposite direction. I applied force down, now it will be applied up. All right, I'm going to take the second ball, pull it back. And what happens? Equal and opposite. I hit it this way and it comes back and hits it again. So that's the equal and opposite reaction here. Notice that the less amount that comes back over on the right, it goes on the same amount on the left. They're exactly equal, and it does opposite. So what I need you to do now is complete your assignment. You have 3 options. One option is to choose your favorite roller coaster ride and describe how Newton's 3 laws of motion are found in that roller coaster. So you can tell me in the first paragraph is going to be how Newton's first law is shown in the roller coaster. Second paragraph, how Newton's second law is shown. And third paragraph, how Newton's third law is shown. Same thing with the next 2 options. Next option, option 2, is sport. Pick your favorite sport and tell me how you see Newton's 3 laws exhibited in your favorite sport. Remember, it must be 3 paragraphs, 1 paragraph per law. And then the third option is how wearing seatbelts can save lives. So a car accident, how the crash test dummies go through a car accident and explain how Newton's 3 laws are exhibited in the car accident. I'm looking forward to seeing your awesome work.